and this is section 5.3, which is on page 302, and this section's called Writing Linear Equations in Point-Slope Form. Before we get into point-slope form, I wanted just to review another form of equation that we've worked extensively on now, and that's slope-intercept form. And now, there's a reason we call this slope-intercept form. I mean, someone was really a genius when they came up with this. They called this slope-intercept form because, as you notice, when you look at the equation, you can look at it and get the slope, and you can look at it and get the y-intercept. That's why it was called slope-intercept form. Can you see in the name, we know the slope and we know the intercept by just looking at the equation. So, when we think about the next form of equation we're going to learn, which is called point-slope form, the name tells me what the equation stands for. It tells me that this equation will give me a point on the line, and it will give me the slope of the line. So let us underline those, okay? This sort of equation will give me any point, or a certain point, I should say, on my line, and the slope. Now remember, slope-intercept form gave me two things also. It gave me the slope and a special point, the y-intercept. Point-slope will give me the slope and just any point on the line, not specifically the y-intercept. Now, the point-slope form equation looks like this. And at first you might be, well, like, geez, that's going to be hard to remember. Well, really, it's not hard to remember. Let me show you where this comes from. Do you remember this formula here? Remember this? This is the slope formula. Well, this equation comes from that formula. All they did is they took the x sub 2 minus x sub 1 and put it over here and multiplied it with m, and all they did was erase the sub 2's, and if you do that, do you notice how you get right to here? So this equation, this form, is derived from the slope formula. So it's the same thing as the slope formula, except instead of having m equaling y sub 2 minus y sub 1 over x sub 2 minus x sub 1, we just have m times the x sub 2 minus x sub 1 and the y sub 2 minus y sub 1 on the other side. Okay, so on this sort of equation, there's a couple things we have to know. The letter m, just like it did in slope-intercept form, still stands for slope. And the y sub 1, x sub 1 stands for a point that is on the line. So if you give me a point on a line and its slope, I can just use this equation to quickly write an equation for that line. It won't be in slope-intercept form, though it would be in a form called point-slope form. Little note here, notice this form uses subtraction. Remember, the slope formula had subtraction, not addition like the slope-intercept form did. And that little subtraction is going to be a big deal. I will show you that in my examples. I think the easiest thing we can do to go through how to write equations in point-slope form, I should say, is just to do some of the problems in the homework together. So why don't you turn to page 305, and that's where I'm at right now. I'm on page 305, and I'm looking at problem number 6. You might want to pause the video right now and go to page 305, look at number 6. It says, write an equation in point-slope form of the line that passes through the given point and has the given slope. So first of all, this is what point-slope form looks like. In question 6, they told me that I had the point 5, negative 1, and the slope was negative 2. Well, here's all I got to do. Take negative 2 and plug it in for slope. And remember, point-slope form means I have a point and the slope. Here's my slope. Here's the point. Take the point 5, negative 1, plug in 5 for x sub 1, and plug in negative 1 for y sub 1. Now remember, I said on my last slide, these subtractions are very important. You got to be very careful with the signs. When you plug in 5 for x sub 1, you get x minus 5 here. But when you plug in negative 1 for y sub 1, you really get y minus negative 1. Now, we don't want to leave this like this. We want to simplify it. Y minus negative 1 is the same as y plus 1. And then we have negative 2 times x minus 5. There's my equation written properly. And remember, this is called point-slope form. Now, it's easy to actually rewrite this into slope-intercept form. Last year when we watched the Khan Academy videos, Sal showed us how to do that, and I'll just show you here real quick. I can easily rewrite this into slope-intercept form if I want. I can start off by distributing here, which gets me down to this first step here. I'd have y plus 1 on the left, and when I distribute, can you see how I'm getting negative 2x plus, negative times negative is positive, 10 on the right. And then I got to get y by itself. Take away 1 from each side. You can see I just rewrote point slope into slope-intercept form. So it's very easy to take point slope form and rewrite it into slope-intercept form, which is a form we've used for the last, actually, several weeks. Let's jump ahead to number 17. In 17, they ask us to graph this equation. For 17, they want us to graph this. So in order for us to graph this, we got to do the following. Okay, we got to get the slope and we got to get the point. So when you think about this, can you see how this equation is written in point-slope form? Here's point-slope form. Now, you got to be very careful. This is the tricky part of point-slope form. Remember, I'm going to put little stars next to this. There are subtractions here. So if this is a y plus 8, does it make sense that we had to have a negative 8 here because y minus negative 8 is what gets me y plus 8? So my y value is a negative 8. And if I have a plus 4 here, that means x sub 1 originally had to be a negative 4 because x minus negative 4 is x plus 4. So that's how I got plus 4, the point negative 4, negative 8 for x plus 4 at y plus 8. So my point is negative 4, negative 8. My slope, you can see it right here. My slope is negative 1. So do you see where I'm getting negative 4, negative 8 from my point, and my slope's negative 1? All I need to do then is go ahead and graph this. So let me graph that for 17. I'm going to do it right now. My point was negative 4, negative 8, which I just plotted. And now my slope's negative 1. That means from this point I should go down 1 over 1, down 1 over 1 repeatedly. And you see that. Take out your ruler, draw a line, you have it. Remember, down 1 over 1 would be the same as going left 1, up 1. I can go in the reverse direction to get more points. So my slope was negative 1, which means rise negative 1, run 1, and my point negative 4, negative 8. I can easily graph a line in point-slope form. In question 16, if they wanted me to graph that, here's my equation. There's point-slope form. Does it make sense that my x value, let me do it in green, must have been negative 6 because x minus negative 6 is x plus 6. That's where I'm getting this from. My y value must have been a 1 because y minus 1 here. And my slope right now is 3. So when I go to graph this, let me graph it again on that next screen. So my point is negative 6, 1, so I can go to that point. I'll just do this in red, even though it's correct, just so we can see something different. My point is negative 6, positive 1, so I go to negative 6, positive 1, and I put a point. There's a point. Now let me get the slope. Remember, point, slope form. My slope was 3. That means rise 3, run 1. So I'm going to rise 1, 2, 3, and run 1. I'm going to rise 1, 2, 3, and run 1. I'll rise 3 and run 1 run, and I will get my ruler out then, and I can draw a line through these points, which I will do right now. and my line would look something like this. There we go. Put arrows at the end, and you have this thing graphed properly. There's the line for the equation y minus 1 equals 3 times x plus 6. In question 18, I won't actually graph the whole thing, but just to make sure we understand what I need to do to graph. There's my equation. Remember, there's point-slope form. Does it make sense that my slope is 3/4? And if I have a plus 1 here, it must have been x minus -1 to start. That's where I'm getting my x value here at -1. And if I have y minus 1, that means I just put a 1 in there. So I have the point -1, 1. Just go to the point -1, 1, plot it, and from there, rise 3, run 4, and you have your graph. In question 20, now in question 20 on page 306, they give me a graph, and they want me to write an equation. Okay, so first of all, if they want me to write an equation in point-slope form, remember, this is point-slope form here, so I just wrote it out. So I need the slope, and I need my point. Well, let's get the slope first. I can get the slope first by just counting squares or using the formula. So go in number 20, put your pencil on the point 1, -3. If you need to stop the video and get to 20, do it. But put your pencil on the point 1, -3. And now from there, count squares up and over. Can you see how if I go up 4 squares and right 2 squares, I get to the point 3,1. So I'm rising 4, running 2, my slope's 2. So I just found out my slope is 2. I'll just maybe put m equals 2 next to that. Okay, and so I can write 2 in for slope. And now I need a point. Well, actually, they give me 2 points. It doesn't matter what point you pick. Doesn't matter what point you pick. So I guess I'll just pick the point 1, -3. So when I plug in 1 for x, when I plug in 1 for x sub 1 and -3 for y sub 1, remember, y minus -3 is y plus 3. And I can plug in 1 for x sub 1. I get 2 parentheses x minus 1. This is a correct response. I'll just circle it in blue. Or Mitchell last year said he picked 3,1 as the point. You notice how 3,1 was also on that graph? I could have picked that point. If you use the point 3,1, you plug in 3 for x sub 1 and y for y sub 1. And this equation would also be a correct equation in point-slope form. Remember, point-slope form means you just have a point on the line, which we do. We have a point either way, and the slope, point-slope form. In 24, it says write an equation in point-slope form of the line that passes through these 2 points. So if I want an equation in point-slope form in question 24, there's point-slope form first. Let me just highlight that again. Now remember, to write an equation, I need a slope and I need a point. Well, I got a point. I need a slope. So let's get the slope. You can see I'm using the slope formula, and I called this point, point 2, and this point, point 1. I'm just applying the slope formula, as you can see. There's my y's being plugged in and my x's here, and I'm getting half for my slope. So now that I know my slope is a half, I can pick either point and replace it in for x sub 1, y sub 1, and write an equation. So if I use the point 12,1 right here, I can use that and plug it in. I would get y minus 1, and then equals half x minus 12. Or, I guess I'll do this one in blue, you can see, or in blue, if I use the point 6, -2, if I plug in 6 for x and -2 for y sub 1. Remember, if I plug in -2 here, I get y minus -2, which is y plus 2, equals half x minus 6. In questions 31 to 34, they're going to ask us if the table we have is linear and explain how you know. It's very easy to tell if a table of points is linear. All you need to do, and I wrote this off to the side, I'll just read it. Here's how you check to see if a table is linear. You just have to find and compare the slopes. You got to find the rates of change. If the rates of change are the same each time, then yes, the table's linear. If they're not the same, then it's not linear. Linear means there's a constant rate of change. It's a straight line, okay? So let's check and see if this table is linear. Well, let's take these 2 points first and find the slope. So I have the point 214 and the point 17, and I'm finding the slope of these 2 points. And when I do, I'm finding out the slope of these 2 points is 7. Okay, so next, let's take these 2 points and find the slope. So you can see I wrote those 2 points down. I put these 2 points into my slope formula. As you can see, I'm subtracting the y's, subtracting the x's. I got the same slope again. Right now, this table looks linear. Let me just make sure. Let me go to my third set of points right here. You can see those third sets of points. I'm finding my slope. I found out the slope is 7. Do you notice how the rate of change is always the same? This table is definitely linear. Okay, my rates of change, my slopes are always the same. Now it says if I can, write an equation in point-slope form. Well, that's easy. I know my slope is 7, so you can see right here, I'll just use a green marker. Since my slope is 7 every time, I plugged in 7. And now all I got to do is take any point on my table and plug it in for x sub 1, y sub 1, and I took the point that I thought was the easiest. I just took the point right here, 1, 7, and I plugged in 1 for x sub 1 and 7 for y sub 1, and there's an equation in point-slope form. This is a linear equation. This table is linear. There's my equation. Here's another example. On 31, we want to see if this table's linear, and then write an equation if we can. Let's see if it's linear. Well, when I take my first 2 points, which I'll just circle here in green, I got a slope of 3. Now let's take the next 2 points, which I circled in blue. And you can see I plug these in, 15 minus 5 for my y, 6 minus 4 for my x's. I'm not getting the same slope. This is not a linear table, so the rate of change is not the same. So I can't write an equation in point-slope for this. This isn't linear in the first place. A couple more questions here, and I'm done. My videos, I want to get this done, and if I can, close to 20 minutes. In 37, we have a story problem. It says, in order to use an excerpt from a movie, in a television show, the television producer must pay the director of the movie $790 for the first 2 minutes, and then after that, $130 a minute after that. And it says, write the equation that gives the total cost using the excerpt as a function of the length in minutes of the excerpt. Okay, well, first of all, this is going to be easy. This is why point-slope form is so great. Right now, I have a slope and a point. Here's my slope. There's my rate of change. It's $130 every extra minute. But do you notice I also have a point? Here's the point. In 2 minutes, we have to pay, the first 2 minutes, we paid $170. So here's a point. Here's the slope. Well, this is easy. Let's put an equation in point-slope form. Now, the only thing in Part A, they said they want me to write my equation so that the cost is a function of the length. In other words, I got to solve this for y. They really want this in slope-intercept form. Well, very easy to do. Okay, to write y as a function of x, get y by itself. So remember, to do that, step 1, let me make sure I marked this so you can see exactly what's going on. To get from here to here, I'm going to distribute first, which is going to get me to this. That's how I'm getting 130x minus 260. Then to get y by itself, I'll add 790 to each side. Here is my equation in slope-intercept form. And then it says, find the total cost of an excerpt that's 8 minutes long. Well, that's easy. Just take 8 and plug it in for x. You can see I did that right here. I just took 8. Where I had x, I just substituted in 8, and when I calculate that out, that means the cost of this commercial or excerpt from this movie is $1,570. And then one final thing, I have a worksheet that you're going to do, and I'm just going to show it to you here. This worksheet says you rent a hotel room for $65 a night. The hotel adds a one-time charge for using its parking lot to the total bill. After staying for 3 nights, your total bill is $270. Now I want you to notice in this problem, they gave me 2 things. They gave me the slope right here. There's my rate of change. My slope is $65 per night. But they also gave me a point. 3 nights cost $210. That's the point 3210. 3 nights, $210. Okay? They gave me a point and they gave me the slope. So to answer this question, I can do the following. Let me go back to here. Okay, they gave me the rate of change. I got to find the additional parking charge. I'll get to that in a minute. There's a point. So they had slope and point. So first of all, I can write a point-slope equation, and I just did. And I'll just circle it here. Can you see my point getting plugged in? And my slope 65 right here. Well, let me quickly solve this for y. So I distributed, you can see that here, added 210. There's my equation. Okay, now, this equation is in slope-intercept form. So remember, the y-intercept is where the graph crosses the y-axis when x is 0. 15 means the point 0, 15. That means when I had 0 nights, I still spent $15 on something. Well, that something was the parking fee. Remember how on the worksheet, let me go back, the worksheet wanted to know the parking fee. Well, there was an extra $15 charge for something. You can see that in my slope-intercept form. At 0 nights, I still spent $15. There's my $15 parking fee. Oop, went the wrong way on that. So my fee was $15. Write an equation. We already did. Y equals 65x plus 15. I already wrote an equation that gives my bill as a cost, as a function of the number of nights in the room. Okay, I already did that right here. After 7 nights, all I got to do is plug in 7. What's the cost? Well, 65 times 7 plus 15 is 470. So I just found out for 7 nights it's $470. And if my bill was $535, how many nights did I stay? Well, all I got to do is substitute $535 in for y, which I did here, and solve this. Well, to solve that, remember, all we got to do is take away 15, which would give me 520 equals 65x, divide by 65, and if I'm doing this in my head right, let me see, 520 divided by 6510, should be 8, I think if I'm doing that in my head right, that's 8 nights stay. We just found out then for the last question, we must have stayed 8 nights for a $535 bill. I'm going to pause or stop the video here, that's been long enough. Questions we have, we can go over if you have more questions tomorrow.